Good morning, everyone. Today I'm going to present the paper Study of CCTV Footage Based on Lower Limb Gait Measure for Forensic Application. My name is Ammar Majid, School of Engineering and Surveying, University of Southern Queensland, Australia, and University of Baghdad, Iraq. I'm sharing this paper with Dr. Albert Chong, School of Engineering and Surveying, University of Southern Queensland, Australia. The aim of this study is to use under the shoes force pressure data to develop a new lower limb biometric measures. The objectives is to determine which lower limb biometric measures are suitable for accurate measurement using photogrammetry and video clip, and to determine the suitability of this measure for identifying perpetrator from suspects based on a sample of 23 adult individuals. Literature review showed that identifying perpetrator using gait characteristic could be the only suitable technique in some crime scenes. A number of authors argued that perpetrators might have walked differently than the normal walking pattern when the crime was committed, which caused matching of the gait pattern with suspects difficult. In addition, there were numerous gait characteristics developed to date, and their effectiveness were not fully understood for small sample size. Gait characteristics such as heel down, mid stance, and toe off could be used as reference marks to enable the acquisition of accurate biometrics measure of the lower limb. We developed methods to obtain accurate three-dimensional distance between the center of the knee and center of outer inner ankle. This figure shows the three stages of the gait: heel down, mid stance, and toe off. The equipment used for this study is a 2-meter foot scan, 2096, long millimeter, and width 472, and the thickness is 8 millimeter plate, and 3D interface box developed by RSC Scan International in Belgium. Each sensor covers 2.2 millimeter square. The plate was composed of 16,384 pressure sensors, and the system is capable of scanning at a rate of up to 500 Hz or 500 measurements per second. We used 3 video off-the-shelf CCTV cameras and laser device to synchronize the camera and the pressure plate. The recruits for this study are 23 adults, male and female, aged 34 plus minus 1 year old, weight 79 plus minus 20 kilogram, and height 171 plus minus 11 centimeter, were recruited to provide gait characteristics data for this research. Methods. The 5-meter walkway was designed to provide approximately 7 to 8 continuous gait, including walking on the pressure plate. Each recruit executed 10 trials starting with left foot. The length of the pressure plate provided a 3 to 4 step continuous gait. Using force pressure pattern of the heel down, mid stance, and toe off, the corresponding video frame were extracted and proceed using the bundle adjustment photogrammetric techniques. As shown in the figure, 3-dimensional distance of the knee and ankle were obtained from the multi-view video frame. Here's the distance we took from knee to inner ankle joint, and here from the knee to outer ankle joint. Results and analysis. Table 1 shows the 3D distance measure of the knee inner ankle at the heel down phase of gait. Table 2 shows the ANOVA analysis statistics group comparison of knee inner ankle at the heel down phase. The overall standard deviation of the trial was plus minus 1 millimeter. The individual group comparison statistics at P equal 0.05 and DF, which is mean degree of freedom of 229 was 1, while the between group results at DF of 22 was around 0.001. Figure 2, scatter plot of 3D measure of knee inner ankle at heel down face. Note the larger error of subject 18. Results and analysis. Table 3, the 3D measure of knee to inner ankle at mid-stance face. Table 4, the ANOVA group comparison of knee inner ankle at the mid-stance face. The overall standard deviation for the trial was plus minus 1 millimeter. The individual group comparison at P equal 0.05 and a degree of freedom of 229 was 1, while between group results at degree of freedom 22 was 0.001. Results and analysis. Figure 3 shows the scatter plot of 3D measure of the knee inner ankle at the mid-stance face. Table 5, the 3D measure of knee inner ankle at the toe-off face. On Table 6, the ANOVA group comparison of knee inner ankle at the ANOVA group comparison of knee inner ankle at the toe-off face. Figure 4, scatter plot of 3D measure of the knee inner ankle at the toe-off face. Result analysis. Note the statistical testing results. Number 1, between group, the significance of similarity between individuals' measure was very small. That means everyone's measure was very different from the others. Number 2, within groups, the significance of similarity within individuals' measure was very high. That means everyone's measure are uniquely different to the others. Discussion. Based on the result of the ANOVA statistical test, it was apparent that the knee inner ankle 3D measure accuracy at the heel down, mid stance, and toe off faces were within 2 millimeter. That means the standard deviation of measure for individual was approximately 2 millimeter. This indicates that the use of knee to inner ankle 3D measure of all three principal faces could be used to identify perpetrator successfully. A conclusion of this study, the research revealed new gait measure utilizing CCTV video footage and pressure data under the shoes. Analyzing showed the knee inner ankle 3D measure accuracy at the heel down, mid stance, and toe off phases were approximately 2 millimeter. A 6 millimeter margin of error was adopted for the determination of between group variation. Further research will continue with the study of knee to outer ankle 3D measure, knee joint ankle and ankle joint angle for three specific gait phases, namely 1, heel down, 2, mid stance, and number 3, toe off. The author thanked the Iraqi higher degree research students group for their participation. Without their enthusiastic support, this project would not have been successful. The first author thanked the Iraqi government for his study support in Australia. Thank you very much for your listening.